Welcome back, Algebra 2. In this video, we'll be using square roots and imaginary numbers to solve the problem that is shown on the screen. Okay, so let's see. We've got x squared plus 32 equals 0. So to start solving, we want to get x squared by itself on one side of the equation. So to start off, I'm going to subtract 32 on both sides so that I can start getting x squared by itself. So that leaves me with x squared equals negative 32. Okay, so now I'm left in a familiar position. So to undo a power of 2, I need to take the square root of both sides. So I'm going to take the square root of the left and take the square root of the right. Okay, so then I see that I've got the square root of negative 32, and I can break that apart. So I've got x equals, and let's not forget the plus or minus component because we've got two solutions. Square root of negative 1 times the square root of 32. Okay, so then we run into this issue of what to do with the square root of 32 because that's not a perfect square number. Perfect square numbers are numbers like, and I would make this list in your notes as well. Perfect squared numbers are numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are numbers where when I take the square root, I get a nice number. 32 is not one of them. But one thing we can do is simplify the square root of 32. Now that's where our list of perfect squared numbers is going to come in handy. What I'm going to do is I'm going to see which one of these perfect squared numbers nicely divides that number 32. I like to start from the very bottom of my list and work my way up. So for example, 32 divided by 100 is not going to give me a nice number. Neither is 32 divided by 81. Neither is 32 divided by 64. Neither is 32 divided by 49. 32 divided by 36 is not going to be a nice number. 32 divided by 25 is not going to be a nice number. Oh, but 32 divided by 16 is going to give me a number that I can work with. So let's go ahead and do that. I know that 32 divided by 16 is going to give me 2. So I can replace the square root of 32 with the square root of 16 times the square root of 2. This is equivalent to this. All I'm doing is replacing that. Okay, and then the next thing I want to do is bring down the rest of my equation. So I've got x equals plus or minus the square root of negative 1. Now, let's do some replacing here because I can replace the square root of negative 1 with an I. So I've got x equals plus or minus I because that's going to replace the square root of negative 1 here. Okay. I can replace the square root of 16 because that is a nice number. The square root of 16 is 4. And then for the square root of 2, well, number one, I can't really break that down anymore. And so I'm just going to rewrite that as the square root of 2. Okay, so now let's write our answer so that it looks just a little cleaner. So mathematicians usually want you to write your answer as x equals plus or minus 4, so that real number first, followed by the imaginary number, followed by the number that's left underneath the square root. And so this is going to be our solution. So we've got 2. We've got x equals positive 4i square root of 2. And we've also got x equals negative 4i square root of 2. Okay, we want to make sure we have both of these solutions in our answer. I want you guys to try one. So here's example. This would be example number 2. Okay, so use square roots to solve each equation, and we want to write our solutions using imaginary numbers as well. So we've got x squared plus 72 equals 0. Try this on your own, and when you come back to class, we're going to discuss the answer.